Hi everyone, thanks for joining today's webinar. I'm Tarun from Zoho Analytics pre-sales team. I'll be the host for today's webinar. I hope my screen is visible and I'm audible. Please confirm. Thanks for confirming. We'll get started with today's webinar. To kick things off, let's take a look at how data science and machine learning fit into our business intelligence workflow. Imagine you're sitting on a treasure trove of data, but without the right tools, the data can feel overwhelming. DSML acts as our compass, guiding us to insights and informed decision making. It enhances our ability to not only analyze the historical data, but also predict the future trends. As we move through this webinar, keep in mind how integrating DSML can empower your analytics processes. Followed by this, we'll explore some common use cases of DSML in action. Next, we'll discuss the DSML lifecycle. Understanding this lifecycle is key to effectively implementing machine learning projects. It typically includes stages like data collection, pre-processing, model training, and evaluation. Our discussions will also revolve around AutoML, what it is all about, and how to use it. Finally, we will check what Code Studio is and how advanced users can leverage this feature. For those who enjoy the flexibility of coding, Code Studio is your playground. It's a place where you can innovate and experiment, much like an artist in their studio. Now let's delve into the DSML workflow within the context of business intelligence. This journey starts with data connection. Imagine the wealth of information residing in various data sources, databases, cloud storage, or even APIs. The first step is about connecting these sources and consolidating everything into a cohesive data lake. So this is where we gather a treasure trove of data, setting the stage for all exciting insights to come. Next, we move to data management, the cleanup crew that prepares our data for analysis. This stage involves cleansing the data to eliminate inaccuracies, transforming it to fit our needs, enriching it to add value, and ultimately modeling it so it's ready for the next steps. It's a crucial process, like prepping ingredients before cooking. Everything must be just right. Once our data is in the top shape, we enter into the realm of data science. So here's where the real magic happens. We build our machine learning models, training them on the prepared data and deploying them to make predictions or classifications. It's not just about creating models, it's also about managing them to ensure they remain accurate and relevant over the time. So it's an ongoing cycle of refinement and improvement. Finally, we reach the culmination of our efforts, insights, and actions. So this is where the data tells its story. We visualize our findings, extracting actionable insights that drive decisions. Collaboration becomes essential here as we share these insights with the stakeholders to inspire action. Whether it's crafting a compelling report or engaging in discussions, this is where the real value of our data shines through. As you can see, each step in this workflow is interconnected, creating a seamless path from raw data to meaningful insights. So moving on, let's explore some common use cases of data science and machine learning in the realm of business intelligence. So these applications illustrate how transformative DSML can be for organizations. First up is predictive analytics. This is all about looking into the future based on the historical data. For example, sales forecasting helps business anticipate the revenue and plan accordingly. Think of it as having a crystal ball that guides inventory management and resource allocation. Similarly, customer churn prediction allows us to identify at-risk customers, enabling proactive engagement strategies to retain them. And then there is demand forecasting. This helps business optimize supply chain and ensure they meet customer needs without overstocking. It's fascinating how predictive analytics can drive strategic decision making. Next, we have clustering. This technique helps us group similar data points together. For instance, in customer segmentation, businesses can categorize their customer base into distinct groups based on behavior, preferences, or demographics. So this enables targeted marketing strategies that resonate with each segment. Additionally, clustering can assist in project workload balancing, ensuring that resources are allocated efficiently across various tasks and teams. It's all about understanding the patterns within your data and make smarter decisions. Finally, let's discuss the anomaly detection. So this powerful technique is crucial for identifying unusual patterns that might indicate issues. Take fraudulent transaction analysis, for instance. Machine learning models can sift through the transaction data in real time, flagging any anomalies that deviate from typical behavior. This not only helps in mitigating losses, but also enhances customer trust and security. As you can see, these use cases showcase the diverse application of DSML and business intelligence. They not only improve efficiency, but also empower organizations to be more proactive in their strategies. Being said this, I'll move to my next slide. Now let's take a closer look at the DSML lifecycle, a crucial framework that guides us through the journey of developing and deploying machine learning models. Understanding the cycle will help you navigate the complexities of your projects effectively. We begin with data preparation. This stage is all about gathering and cleaning your data. It's like preparing a canvas before you start painting. You want to ensure that your data is accurate, complete, and structured properly. This might involve handling missing values, removing duplicates, and ensuring consistency across data sources. A well-prepared data set lays the foundation for the successful modeling. Next comes the ML model building. Here's where the creative process begins. In this stage, you select the right algorithms and techniques based on your specific goals. Whether you're building a predictive model or a clustering algorithm, this is the time to explore different approaches to see what works best for your data. Following that, we move on to training. This is the phase where the model learns from the data. Think of it like teaching a child, providing them with examples and allowing them to understand patterns. The quality of your training data directly influences the model's performance. So it's essential to monitor this phase closely. Once the training is complete, we enter the analysis stage. Here you evaluate the model's performance using various metrics. Are these predictions accurate? How does it perform against the validation data? This step is critical as it helps identify any adjustments needed to improve the model's effectiveness. Next, we transition to deployment. After rigorous testing, it's time to bring your model to life. This involves integrating it into production environments where it can start delivering real-time insights or predictions. It's an exciting moment as your hard work begins to pay off in tangible ways. Finally, we wrap up with manage and monitor. This is an ongoing process that ensures your model continues to perform well over time. Data changes, user behavior evolves, and models can also drift. So regular monitoring is very essential. So this stage involves fine-tuning and retaining as needed, ensuring that your model stays relevant and effective. In summary, the DSML lifecycle is a continuous loop of improvement and each phase is interdependent. By understanding and embracing this lifecycle, you'll be better equipped to implement successful DSML initiatives in your organization. Now let's explore some of the exciting DSML features available in Zoho Analytics that can elevate your data science capabilities. First up is AutoML. So this feature is a game changer, making machine learning accessible to everyone regardless of their coding skills. With AutoML, you can create powerful models using a no code assistant. Imagine being able to harness the power of machine learning without needing to dive deep into complex programming. This feature empowers business analysts, marketers, and decision makers to generate the insights quickly and effectively. It's like having a personal data scientist at your fingertips. AutoML streamlines the entire process, guiding you through data preparation, model selection, evaluation, making this incredibly user friendly. So, whether you're looking to predict your customer behavior or optimize your sales strategies, AutoML provides an intuitive way to get started. Next, let's talk about Code Studio. For those who prefer a more hands on approach, Code Studio is the perfect solution. This feature allows you to develop custom models and functions using Python, providing the flexibility to tailor solutions your unique business needs. In Code Studio, you can dive deep into your data, experiment with different algorithms, and even integrate external libraries. This is where you can truly unleash your creativity and technical skills to build sophisticated models that drive deeper insights and more impactful decisions. Together, AutoML and Code Studio cater to a broad audience from beginners wanting to dip their toes into machine learning to seasoned data scientists looking to craft bespoke solutions. So, whether you're just starting out or looking to elevate your analytics game, Zoho Analytics offers the tools to make your DSML journey both exciting and productive. Now, I'm excited to take you into a live demo of the AutoML feature in Zoho Analytics. This is where we'll see firsthand how easy it is to create powerful machine learning models. So, when we select AutoML, the first thing we encounter is the model type selection screen. So here we have two primary options, the prediction model and the clustering model. So let's start with the prediction model. So this type of model is designed for making forecasts based on historical data. For instance, if we want to predict sales for the upcoming quarter based on the past performance, this is the model we would choose. It leverages regression techniques to understand relationships within data and provides us with actionable insights. On the other hand, we have the clustering model. So this model is perfect for grouping similar data points together. For example, if we wanted to segment our customers based on purchasing behavior, a clustering model would help us identify distinct groups within our customer base. This is invaluable for targeted marketing strategies and resource allocation. As we move through this demo, I will show you how to select one of these models and guide you through those steps to create it. This process is designed to be user-friendly, making advanced analytics accessible to everyone, regardless of their technical background. So let's dive in and see how we can leverage AutoML to generate powerful insights. A quick demo showcasing the process of AutoML. First, I'm selecting AutoML. So in this demo, I'll be using customer churn data as a training table. So I'm creating a new analysis. So I'm doing this analysis to find whether the customer will churn or not. So here you can see the model types, prediction and the clustering model. So I'm going to stick with the prediction model. I'm choosing the training table and the target column. The training table is customer churn data and the target column is the attrition flag. So this column indicates whether a customer has churned or not, which is crucial for building a predictive model. So we have completed the first step. Now the next important step is to train the data set. Now that we have selected our training table and the target column, it's time to dive deep into the crucial steps of training our data set. So this step involves splitting our data into training and validation sets. The training set is what we use to teach our model, while the validation set helps us evaluate its performance. It's essential to ensure our model learns effectively without overfitting to the training data. This balance is key for building a robust predictive model. Next, we have the feature engineering. So this is one of the most powerful aspects of machine learning. Feature engineering involves selecting, modifying, or creating new features from our data set that will help improve the model's performance. For example, we might create new variables that capture interactions between existing features or transform raw data into more meaningful formats. The right features can significantly enhance our model's ability to make accurate predictions. Finally, we move on to hyperparameter tuning. Think of hyperparameters as the settings that dictate how our model learns. Adjusting these parameters can lead to a better model performance. During the stage, we systematically test different configurations to find out the optimal setting. This might include adjusting the learning rate, the number of trees in a decision forest, or the depth of a neural network. Effective hyperparameter tuning can make a substantial difference in our model's accuracy. Together, these steps form the backbone of our training. So this forms the backbone of training a predictive model. Let's now see how AutoML handles these processes seamlessly to deliver a powerful model for predicting customer churn. So I'm training the dataset, I'm giving the analysis a name. You can add the features. Features are nothing but the data columns. By default, the tool selected these columns. On top of this, you can also select the additional columns that you think would influence the customer churn. So I'm selecting customer age, customer ID, number of transaction, amount change, quarter 2, quarter 3, along with the other features that has been selected by default. Now you can add the algorithms. By default, the tool suggests that decision tree classification and random forest classification will work best for our dataset. On top of it, I'm also selecting other algorithm. I'm choosing gradient boosting classification, and I'm giving the loss function to be least squares, and I'm providing the number of trees to be 35. I'm selecting OK. And now I'm going to select create and train. So here you can choose the server options. Depending upon the size of your data, I suggest you to choose the server option. Suppose if you have a large data set, you need to choose at least 32 GB to compute effectively. So we saw how to train the data set. Being said this, we'll move to the next step. Once a data set is trained, we arrive at the crucial step, which is to review the model summary and its performance metrics. This is where we can evaluate how well our model is doing and understand its key characteristics. In the model summary, we will find a detailed explanation of the algorithms used, the features selected, and how the model arrived at its predictions. This transparency is essential because it helps us understand the logic behind the model's decisions and the factors influencing the customer churn. This summary serves as a foundation for our next steps, whether it's deploying the model or refining it further. Let's take a closer look at the specifications of model's performance in our demo. After training the dataset, I have the model summary. If you remember, the tool suggested decision tree classification and the random forest classification initially. On top of that, I selected another algorithm, that is gradient boosting classification. If you look at the model score, the gradient boosting classification has a poor score. So it is advisable not to go ahead with this model. I can see decision tree classification has the highest score. So I'm going to select that model. I can see the model details. I can see the model type, model score, minimum sample split. I'm going to the explanation where I can see the feature importance. As I mentioned earlier, features are nothing but the data columns. So the report tells how each feature is influencing the customer churn, how each data column is influencing the customer churn. From this report, I can see that the number of transaction change Q2, Q3, and the amount change Q2, Q3 is influencing my customer churn a lot. So compared to the other features, these two features are influencing a lot. You can also go to the partial dependence. And here you can select a specific feature or a data column and see how it is influencing the customer churn. Now I'm going to the performance and I'm selecting the confusion matrix. If you look at the confusion matrix, you can see that the decision tree classification is the best model because the actual yes and the predicted yes is 1270. The actual yes is nothing but the actual customers who got churned. The actual yes and the predicted no, there is a discrepancy of just 5. The actual no and the predicted yes is 0. And the actual no and the predicted no is 100% perfect. It is 6,725. So the number of customers who didn't get churned is equal to the number we predicted. So this is the best model I would like to go ahead with. Now that we have our results and the decision tree classification model has shown a good score, we can confidently move forward with deploying this model. Here you see the decision tree diagram. This visual representation illustrates how the model makes decisions based on the features we have engineered. Each node represents a feature and each branch signifies a decision rule that leads to a specific outcome, either predicting the customer churn or not. The flow from the root to the leaves demonstrates the process of splitting the data based on feature values. This hierarchical structure allows us to trace the path of any given prediction, providing transparency into how the model arrived at its conclusion. Being said this, we'll move to the last step. So this is deploying and managing the model. With our decision tree classification model ready, we can now proceed to deploy and manage it. Deployment is a critical step as it allows the model to start making predictions in a real-world environment. We'll integrate it into our existing workflows, ensuring that the stakeholders can access its insights seamlessly. Once deployed, managing the model is also equally important. This involves monitoring its performance over time, ensuring it remains accurate, and making any necessary adjustments as data changes or new patterns emerge. Regular maintenance will help us sustain the model's effectiveness and reliability. Now I'll quickly deploy the model. I'm deploying the decision tree classification model. I'm providing the input table and I'm naming the output table. So I'm providing the prediction column a name. So this final column will have the result whether the customer got churned or not. I'm choosing the server option and I'm selecting deploy. Deployment status is a success and this is the output table. So here you can see the last column that shows whether the customer got churned or not. I have also built a pivot table on top of this output table. So this report shows the churn analysis. So here you can see the different features such as the gender, customer age, transaction amount, attrition count, attrition percentage, retain count, and the retain percentage. So this is how you can train the data set and see the model summary and deploy it. Now let's shift our focus to Code Studio. So when we click on the Code Studio button, we are presented with two powerful options: ML model building and data transformation. ML model building allows users to dive deeper into custom model development. Here you can write Python code to create tailored machine learning solutions that fit specific business needs. This feature provides the flexibility to implement complex algorithms and leverage external libraries, making it ideal for data scientists looking to push the boundaries of what's possible. On the other hand, data transformation is essential for preparing datasets before modeling. This option enables you to manipulate, clean, and enrich your data programmatically. You can automate repetitive tasks, creating new features, and ensure your data is in optimal shape for analysis. Both of these features empower users to harness the full potential of their data science projects. In the upcoming slides, we will have a quick demo video showcasing how to use both ML model building and data transformation in Code Studio. Let's take a quick look at it. So now I'm going to use Code Studio for building a machine learning model. So I'm selecting Code Studio. I'm choosing Create New, and I'm choosing the ML model. You can just write your own Python code to build the machine learning model. I'm just writing a Python code to do a credit analysis. So once you complete your coding, you can train. So once the coding is completed, you can go ahead and train. Now we look at how we can use Code Studio for data transformation. You can just select Code Studio, choose Create New, and select Data Transformation. And then you can write your own Python code to transform the data. I'm just writing this code to do sales analysis by hierarchy. You can do a test run. You can do a test run and see the output. If you're happy with the output, you can go ahead and deploy. The output looks good. So I'm going to deploy it. You can choose the compute size as per your requirement. You can also schedule this if you want. Now we have the output table. So this is how you can use Code Studio to transform the data. We saw how we can use Code Studio to build a machine learning model, as well as how to use Code Studio to do a data transformation. I would also like to inform you about some important features. It is possible for you to import external Python libraries and do the transformation. We also have Ask Zia present within the Code Studio interface. So you can just ask Zia your doubts directly and get the syntax. A quick video of how this can be done. I have the Zia interface. I can just ask the code I need. So I have just typed, I have a data frame with age, number column. So give me a code to bin with name as age binned. And it generated the Python code. I can just copy it and include it within the other lines of code. And I can deploy it. So this is how easy it is. So this AutoML and Code Studio is available only in the enterprise plan of Zoho Analytics. So these features work as a pay-as-you-go model. By default, your enterprise plan will have certain credits. 1 GB deployment server will consume 1 credit per minute. Once your credits are exhausted, you can purchase the add-ons from the store. So we have come to the end of today's presentation. I'll now open up the floor for questions. Anybody who has any queries, feel free to let me know. I'll be happy to answer. Attendees who want the recording of this session, please do let me know. I hope I was able to answer all of your questions. If you have any further questions, you can feel free to drop an email to support@zohoanalytics.com. Thank you all for joining the webinar. It was great interacting with you. Have a good one. Bye.